Hello, everyone. It is October 8th, 2022. Tuesday, October 4th. Sorry, did I say October 8th? October 4th, 2022. Welcome, everyone, to the stream. Thank you for hanging out. If you're in the chat, let me know by saying hi. I'm going to test the chat. Oh, and I'm realizing that I forgot to change on this view. But we're going to get into it today. I'm really excited for our stream today. We have a lot to go over. If you've been following along with the stream and you know anything about the stream, we have been putting on our very own Kaggle competition. And this week, just yesterday, it completed and we have a winner. Hey, good evening. Hello. Hello, everyone in chat. How's it going? We have Nis there. We have Kidisha. What's up? So let's go ahead and switch over to here. We can see yes, we do have the chats now coming in. Good evening, Architect. How's it going? So we do have our competition, which ended this week, and we're going to go over it a little bit. It was a great finish. Thanks to everyone who competed. And you see that GPU back there? Well, it's right here. That 3080 Ti. I'm going to send that GPU out to our winner this week, and very excited for them. Let's just search for the corn competition. Oh, it's not going to pop up. Community competitions of corn. PogChamps number 3. So we ended up with over 92 teams, which was pretty strong showing given the fact that this is just our third Kaggle competition, and there were a lot of really awesome submissions that we had up there too. It's not like we had 92 teams and no one was really competing. The top teams really were pushing it. Hey, Andrew Spears. Hey, we have our winner in chat. How's it going, Andrew? Congratulations on your win. So yeah, let's look here over at the leaderboard. We see here at the top, Andrew had a big jump. Now, one thing I want to mention about this competition is we knew that there may be a shakeup on the leaderboard, given the fact that I only had 20% of the test data as our public test. So you know then that you need to trust your local evaluation, because with only 20% of the test data being public, that means that there's a potential for a big shake. Now, there wasn't that big of a shake as you would think. I mean, some teams moving up 20 spots, more or less. Andrew did jump up 18 spots. So, yeah, awesome to have you in the live stream, Andrew. Great job. We're going to look over your solution here in a second. But awesome work here. I was surprised here, and I'm not going to lie, Andrew. I was a little bit worried because I saw your account that you were only a contributor, not really that active on Kaggle. And then, well, I guess you have a lot more stuff now. But before you had no competitions, no real discussions. And I thought, maybe this is someone's fake account and they're just cheating here. Somehow, you know, it was possible to go cheat, but Andrew did a great job writing up his solution with all the details and actually doing a great job of documenting everything in a notebook. So congratulations, Andrews. We have Chumajin, who got second, and Ayukashaman as third. Hey, welcome to the family. We have someone new here. Gopher. Welcome to the family. Glad to have you here. So we're going to take a look at some of the top solutions. I also want to let you all know that we do have a survey here. I know everyone's favorite thing is to go into surveys, but we do have a survey that I'm going to put in the chat. This is a Survey Monkey for anyone who has competed in the competition or knew about the Kaggle competition that we're putting on. Please check that out and let me know. Give me some feedback as to how you felt the competition went so I can make it better next time and we can keep on improving it. So, yeah, thanks everyone for hanging out with us tonight. We're going to go over some of the solutions. Just a reminder, if you don't know what this competition is or what it was all about, it started about 2 weeks ago. 16 days ago to be exact. We released a bunch of data that was images, a bunch of images of corn. And the competition was to design an algorithm that was capable of deciphering what classification to give each image of corn. And the classifications were either pure, that they were perfect, broken, discolored, or silk cut. And it's a multi-class classification competition. Hey, Zed Tell, welcome to the fam. So it was cool to see everyone's different approaches to this. Obviously, it's a very standard sort of setup for image classification where you're given a bunch of different images and their labels, and you had to train a machine learning model that could detect which classification to put it into. The metric that we were using, the valuation metric, was just classification accuracy. So the amount that you did correctly. Kadisha is asking, when's the next competition? You guys are already jumping on me for the next one. Hopefully soon. I honestly, we need to get some more sponsors. If you guys have any suggestions as to who we could reach out to, that would be cool. But I think it definitely makes it a lot more fun when there's something like that GPU on the line. So, yeah, I think we might take a little bit of time off, reevaluate, and then definitely launch another competition at some point, which would be our 4th PogChamps. Pretty awesome. So yeah, we're given all these images. You got to evaluate how well you did at predicting. And then, of course, thanks to NVIDIA, our sponsor here, we're giving away this 3080 Ti GPU to our top place finisher. So Andrew, that's going to be sent to you. Congratulations. I do want to, just early on here, get in here. So we do have, for the 2nd and 3rd place competitors, we have Deep Learning Institute vouchers that I'm going to be giving out. And we also said we were going to give out a Deep Learning Institute voucher to a random chatter in the Twitch chat. And we are going to be giving away, it to the best notebook as voted on by you. Live coding time for everything to run perfectly on the first try. Database success. That's exactly right. Kadisha said you can help out with getting sponsors. Yeah, definitely reach out to me on Twitter or through Kaggle if you have any hookups. That would be very cool to hear about. Is Kaggle an appropriate site to start getting involved with data science with zero previous coding experience? It may be a little bit tough if you have zero coding experience. I would probably recommend checking out, a basic Python beginner's course if you're just getting started out. And then after that, maybe like an intro to machine learning course. But I will say that Kaggle does have some of its own learning stuff here. So you could just try to start, if you're going to start brand new, start by doing some of these courses like Intro to Programming and Python. These will probably get you started out right. So you could do your Intro to Programming through here. I haven't heard that many people doing it this way. There's also some courses I recommend, like the MIT X Intro to Python. Actually, if you do !YouTube, you can check out my YouTube channel, which those of you who are watching on YouTube probably already know about. And I have a video on like getting started in data science. I would recommend checking that one out. Machine learning, how to get started. Yeah, this I'll put into chat, and this would be the one that I recommend to watch. But great question there. Yo, how does that data scientist life on a Tuesday night? Pretty good, Herbie Hoover. How are you doing tonight? POG stands for one. It is POG is like a Twitch meme for, I think its origins go way back to this old video where I don't know if you guys know POGs. It's like these little bottle caps, like paper bottle caps. Let's look up PogChamp origins. Oh, look, there's a whole Wikipedia article on it. So it's intended to express excitement, intrigue, joy, or shock. So I did kind of steal the PogChamp name from chess.com's site. They have a PogChamp series also where they take famous Twitch streamers and they have them play chess. And they're not necessarily all amazing chess players, but it's fun to watch. Go on. Felipe says you're Brazilian. Welcome from Brazil. Yeah, Pog was a sweet game for us 90s kids. I remember, tell a little bit of a side story. I remember when I was in middle school, I think, and kids would play Pogs, which is this game where you just have these like little circle piece of paper, the like cardboard paper with different images on them. And they're kind of like trading cards, but you play this game where you would try to flip them. So you would challenge someone else. You'd have them both face down and then you try to flip them. And if you flip both of them, then you would win them. So you would actually take them from the other people. Sometimes you play for keeps and sometimes for not. But I remember kids, there may have been some kids in our middle school who put tape on the bottom of their shoes and they would just walk around and kick over people's Pogs holders and then step on the Pogs to see how many they could just walk away with. There may have been some kids who did that. I'm not going to name any names, but that may have gone on in my middle school. Not cool, looking back on. Very not cool to do, by the way. Don't do that. Rolling with these custom Pog slammers. Yeah, slammers. Those were the things you used to like flip over the Pogs. Hey, Nick Mombi, welcome. So, back to this. We're going to give a prize to the top notebook. There was a lot of awesome sharing in this competition, and honestly, I've learned a lot. There's still a lot to learn, but I've learned a lot just from reading the top solutions to this competition. There are a lot of use of transformer-based vision models, which have, I guess, gained a lot more popularity in recent years. I haven't competed in an image competition on Kaggle in a little while, but back then it was like efficient net was everything. And now it seems like these vision transformers are really becoming powerful. And people use VITs. I've used those before, but especially in this competition, we're going to see how those vision transformers worked really well. Data Crusade 1999, welcome to the family. Good to have you here. Hope you're doing well. So, way we're going to do this, and if you're not on Twitch, come over to Twitch and join us. It's right here. Going to put this in the chat. Definitely come over to Twitch and vote with us. We're going to vote on the best notebook. Now, I could take every single notebook and I could try my best. Yeah, I think it's just too much. So what I'm going to do here is I'm going to take however many the voting lets me take of the top voted on notebooks, and we're going to vote individually on those. Andrew Spears, hey, you're on Twitch now. Nice. Awesome. Glad to have you here. So we are going to make this survey, and I'm going to highlight these top 5. Let's start with this one. I'm going to put this in as number 1 into chat. This is, so the first one is the Corn Seed Labels and Dimensions. The second one is Fast AI Baseline. Now, Fast AI was used in the top solution here. That's going to be number 2. Another Fast AI Baseline, and this is a CNN base, number 3. Hey, R1 Auger, welcome to the chat. I hope you're doing well. All right, number 4 is this one. It's Corn by SO. I don't think I've seen this one that much detail, so definitely check this out. And Mariella Prada's CNN MobileNet model. And there are some memes in that one. So we're going to vote on these. I don't know if it'll let me get a 6th in there. We'll try. Manage a poll. New poll. And we're going to make this 10 minutes. Yeah, it only gives me 5 spots. So I'm going to make it vote on your favorite corn notebook. All right, so you guys have the links there. You have the links there. We are going to look at these in a second, but so number 1 is this corn seed. Number 2 is the augmentations. Fast AI. Number 3 is this one. CNN Fast AI Baseline. Number 4, I'm surprised none of the exploratory ones got here in the top. Number 4 is Corn by SO. And CNN Mobile Nets, number 5. How many projects do you recommend I do to become proficient enough at data analytics? 2310 Sammy. I don't think I've ever felt like I'm proficient enough. It's always something where you feel like you can constantly get better and learn. Your image processing video really helped with the EDA. Thanks so much, Nick Mombi. All right, so we're going to launch this poll. 1 vote per participant. I don't think I allowed extra. That's the poll right there. Feel free to vote on this one with your favorite notebook. I linked all of them in the chat. Hopefully you guys can open them up if you want. Again, number 1, we have the It's Corn image labels and dimensions. This is some exploratory analysis and looking at the dimension relationship. I think there was, some box plots, some bar plots to see what the labels were. This is a Fast AI albumentations. Albumentations? Am I saying it right? Albumentations. Notebook showing using things like cutout augmentations where you kind of add these black squares to the images when training or during test time augmentation. And yeah, this is a great example of that. This one, Ningi notebook. I remember this one. It's got this very, very cute corn at the top. Did some exploratory analysis and a lot of I'm going to put my vote in. Maybe I shouldn't vote. That wouldn't be cool. But this one is really good is what I'm saying. And a very clean notebook, I would say. This well organized and really good explanations. And then it's Corn by SO. Got some corn kernels here at the top. So check this one out. We got some augmentations talking about overfitting. And then Mariella's one, which does have some pretty dank memes. Okay, so you guys are voting on that. While that's going on, we can see, okay, we got 2 votes coming in. Feel free to vote, people. You are not asking me my tape, but I say do as much as possible. Go all the way. Never stop. That's a good suggestion, Pon. 23,110. I want to complete at least 3 by the end of this month. Complete 3 what? Complete 3 competitions? That's pretty ambitious. But definitely keep going. Never stop. All right. So, yeah, let's talk about some of the top solutions. All right. So how did people approach this? And let's recently posted. Let's look at, should we start from the top and work our way down or go the opposite way? When Rob going to tell us that he was the one who labeled all the corn images? Yeah, Matt, I went through all the corn and I'm the expert. There were people asking about that who did it. Oh, by the way, let's shout out to the corn. I mean, it's not that hard to find this data set. So this is the data set and we're going to give it its proper shout out in chat, and I'll put it on the link. I didn't want to obviously link to it during the competition because that would kind of point everyone where to look for the answers. But I did use this data set, which was provided and is open for using for research like we were using it for. And thank you very much to this research team that created it, labeled it, and they also did their approach, which if you want to read their paper, what they did was they created a GAN to actually make more images. I was surprised that no one in this competition did that. I don't know if it actually would work in this Kaggle competition, but they used a generative additive model to create more samples to train on. So definitely thank you to these people who created. I'm not 3 projects from analyzing data in reports. 2310 Sammy says. Oh yeah, I totally agree. That makes sense. 3 projects in a month, 1 a week sounds about good. I support it 100%. All right, we're tied 2-2 in the race for the best notebook. Alrighty, so yeah, let's go from number 1 down. Let's start at the top, and we'll see a lot of common threads here. In this, you'll see when you look at the top solutions for any competition on Kaggle, is a lot of time there's a lot of overlap, and then surprisingly, you'll see people that had completely different approaches also do well together, and that just shows that diversity in your model solution usually gives you a better overall score on the private leaderboard. If you're taking a robust solution with a bunch of different approaches and combining them, it usually does pretty well. So, hey, Europa, welcome to the family. How's it going? So let's start with Andrew, who's here with us, solution. I'm not going to read everyone's solution in complete detail, but I am going to go over the general points. So the one thing I will say about what Andrew did here, which was really impressive, is he linked to his GitHub repo where he had every step written out. I haven't gone through and actually looked at all of these, but he did use Fast AI. You can see the first one is initial experiments, and you can kind of go through here and see the steps that he took in order to get to his winning solution. So there was a lot of work that went into it, and it becomes clear when you see it here. You can see also some good documentation written up on what actual was used in the solution. I think it's the same write-up as we're going to read here on Kaggle. So one common thread I've noticed here, and you guys can tell me, Mr. Gabriel Blintz, first time watching. Good night to you as well. First time watching live. Okay, cool. Well, welcome. I'm glad to have you here. So let's look into what this solution was. Honestly, I thought it was going to be a candy corn poll. What's a candy corn poll? So a lot of people used Fast AI deep learning framework, which is great to see. I've said it in the past, I've tried Fast AI and it never really caught on for me, but that was a few years ago. So Fast AI in both this competition and the last competition were heavily used by really successful participants. So I think that that's to say, if you're getting started in deep learning, it may be something that you want to go out and check out. Fast AI is, number one, a framework. So like a package and a library you can use in Python for training these type of neural networks. But also there's a course that goes alongside it that kind of steps through how to use it and the reason behind why you use each of the steps. I think that's a good explanation for what it is. For someone who hasn't really done the course in a while, correct me if I'm wrong. Leaderboard changes were insane. Yeah, we talked about that, Mr. Gabriel Blins. That tends to happen, especially when you have a small public leaderboard. So people can really overfit that leaderboard. Ishwari says, give some tips to study Python. Check out my YouTube channel. I got a bunch of them, bunch of tips. Won't go into too many details. What distinguishes a library from a framework? That's a good question. I don't really know the difference technically. So it's whatever you want to call it. It's a library / framework. Let's call it. So what sort of models were used? Most of them are going to be used from the TIM repository. TIM is the PyTorch image models repository that is standard and used across Kaggle competitions often. Definitely check this out if you haven't already, this GitHub repo that kind of talks about it. But basically it gives all these different architectures, gives you an easy way to access the different architectures using that package. So not only does FastAI a framework, but I guess it's built on top of other libraries. So everything in code kind of inherits from other stuff, right? Almost signed up for an introduction to Linux class, but it's $169. Don't spend money, spend time. Jack Dawes, thank you for the appreciation. I appreciate that back. Thank you. Namaste. We stand on the feed of giants. Lopta, was that a correct statement? Was that a Freudian slip? All right, so Cov Next Large, VIT, that's a vision transformer based model. And then these Swin models. Swin models are new. I don't know much about them other than they're transformer based. And I think they're good for like picking up on small changes, like at the pixel level between images and noticing really what to focus in on the image. Now, in this competition, we noticed that some people had noted that the classifiers were actually picking up on the shape and the background of the image. And since we had top and bottom image views of each of the corn, it's kind of important for the model to be able to determine what part of this image to focus in on, to sort of ignore this background and focus in on the seed part, because that's what it's actually using to classify, right? So I guess these Swin models do really well on that. I had 2 days at home this week, count for positive COVID tests. Oh, sorry, Lopta. Yeah, at least you can breathe. That's always better than, when you get COVID, you got to take a chill pill, hang out, ride through it. You'll get through it. All right, so one thing you'll notice too is that there are a bunch of different experiments that were done. That's another thing that you'll see in a lot of winning solutions is that you try a lot of things. Some may fail, most may fail even, and then you just focus on the things that work and do well. And you evaluate what does well based on cross-validation. Not necessarily only on the leaderboard, but if you see a correlation between the leaderboard and your local cross-validation, you want to kind of stick with that. Is it possible to get the same results by using TensorFlow / Keras? PyTorch and FastAI are being very dominant. So in theory, with this TIM library, you should be able to import all the architecture into TensorFlow, Keras, or PyTorch, or FastAI. Or FastAI, I guess, is built on top of PyTorch. But regardless of the back end, the architecture should stay the same. So if the architecture is the same, you're training with the same learning rate. All the TensorFlow or PyTorch is doing is it's doing the math equation to find like the optimum weights within this model to satisfy whatever loss you're giving it. So in theory, if you're using the exact same parameters, you should be able to, in a sense, recreate the exact same results. PyTorch or Keras TensorFlow, the same. Now in practice, it's not always that easy. And part of, I think, what FastAI does really well is helps you find that learning rate to start on, and that can be really important, especially for training these image classifiers, where getting the correct starting learning rate is really important in order to reach that optimal point. So definitely check out Jeremy Howard's FastAI course if you haven't already. All right, so let's look at augmentations. Random flip and rotate only. Random flip and rotate with small cropping. Rotate with small lighting, cropping, and warping allowed. So that's interesting that the augmentations weren't that strong. Sometimes you'll see solutions with incredibly strong augmentations. And I guess the amount of augmentations you add may actually impact how much you have to train, because the more augmented your training data, the longer it's going to take to fit the model. It's doing the grunt work for the algorithm. Yeah, kind of, Lopta. It's automating the part that's not automated already, when most of it is. It follows some learning rate schedule and freezes parts of the network in ways to make most networks train well. Yeah, that is Andrew Spears. That's a good point. Explanation at high level in 10 seconds. Yeah, you can freeze up to certain points, right? And you can freeze certain layers in the model. So that's a good point. That's something that FastAI definitely does well. It also kind of makes it more of an iterative process to reach that optimum. At LOQ, welcome to the family. Thanks for joining us. Glad to have you here. Hope you're doing well. So yeah, Andrew, I know you're in chat. If there's anything else from this that I should kind of jump into, he gives a bunch of shout outs here. Everyone should check this out. And congratulations to Andrew for your first place solution. Great job. We can look at the second place solution and just maybe note some of the differences. So Chumunjin did not qualify for the prize because the submission was not made through a notebook. That's one thing to note here. So I guess this is like a 2 with an asterisk on it. So bunch of different models. Let's see if there's the Swin large is here. Swin large patch 4. Yeah, thank you, Andrew. Congratulations. And I'll be sending that GPU to you very soon. So FastAI again, one fit cycle, FP16. So that allows you to basically get twice as much of bang for your buck. What floating point 16 allows you to do is use less space on your GPU and actually less computation time and really get the same results as if you use floating point 32. So most people use floating point 16. Pseudo hard labeling were used for some models. So yeah, that's interesting. Oh, the other thing is, I think that Andrew mentioned it, but using test time augmentation is an approach where you actually augment the images that you're predicting on. And it looked like a lot of people did that. Is that single precision floating point? Maybe Lapta, I'm not sure. Yeah, a lot to learn from all these solutions out here. Congrats, everyone. Great job. All right, third place. The interesting thing about this is Ayuga's men said mainly wanted to use transformer attention-based vision models. So this is where the SWIN model comes in, and these BIT model. BIT. It's like a BERT-based image transformer-based model. Man, these models are getting crazy. It's hard to keep up with all of them. So yeah, these are like the state-of-the-art, the really cutting-edge type of models that are being used in his solution. Also showing us here using augmentations, all the different augmentations being used. And then these are the 4 times TTA test time augmentations that were applied during the prediction phase. Okay. And then also using some mix-up. So I remember I had, back in the day, I had had to write up the mix-up augmentation myself from scratch, but I guess there's an implementation now. Yeah, so I think I may have used this implementation too. Tim has, mix-up within their library. So what mix-up does is it basically, instead of feeding the exact image into the model when training, it combines 2 of the images to the model as an image, and then it gives it the labels of the average of the 2, depending on what level that you apply the mix-up. Hey, Kenjito, too. Welcome to the family. Thanks for joining. Let me know in chat how you found it. Yeah, some great work here. So definitely good job on third place. Let's go down the line. Fourth place we don't have yet. Hopefully we'll get 5th, 7th, 11th. Also, let's go back here. Albumentations Fast AI is the winner of the notebook challenge. So congratulations to whoever won that. Mr. Gabriel Blins, thank you for subscribing. You don't need to subscribe, but when you do you know what happens? We spin the wheel of destiny. So let's do this picker wheel and spin it. That's what I do when we get a subscription. Thank you so much, Mr. Gabriel. By the way, if you have Amazon, if any of you out there have Amazon accounts and you log in, gotta type pizza 100 times, and you log into that, link that to your Twitch account, you get 1 Prime subscription for free every month. Doesn't cost you a thing. So let's go to Sublime Text. Find my pizzas. All right. I have typed pizza 1,500 times on stream. 100 more to go, thanks to that subscription. So while I'm typing this, let's talk a little bit more about what we're going to do tonight. We're going to look a little bit more over people's solutions. Maybe not get that more into it. Reminder, there is a survey out there. If you took part in the competition and you want to give some feedback, that would be great. Let me know what you want to see in the next competition. Man, mistyped that one. Yeah, or if you have any other feedback as to how you thought it went. I thought it went great. You guys did such a great job of sharing the right amount, not too much. Also, afterwards, all the different solutions that were written up, I was very impressed and encouraged by the way people came together on this competition. And working on, someone noted this in the discussion, but working on kind of a small-ish image data set like this in a controlled environment like a Kaggle competition, I think can be really helpful, because a lot of times on Kaggle competitions nowadays, the data sets are so large that you kind of need to know where to start. All right, there we go, 100 for you. Why are you writing pizza? Okabe side, because every time that I get a subscriber on Twitch, I spin this wheel and I do whatever it says. So if it landed on 10 push-ups, I would have done that. And we just got a new subscriber and I had to type pizza 100 times. And as you can see, I've written it on my stream before 1,600 times. So we've been here before. Yeah, so I really think working on a data set this size is great for people trying to learn, because you have a good size of data that you can still train the model on, but you don't have to spend hours and days just to get results back from your experiments. So I hope that everyone kind of enjoyed this, learned a lot. Keep your eyes open. Keep your eyes peeled. Maybe I'll do a banana competition. Keep your eyes peeled for the next competition, whenever that may be. And that's to be determined. Anything else we want to go over? In chat, let me know if you have any questions about this competition before we officially close it out. We have our winner of this, which is Alimentations. Need to remember this. Congrats. You won the notebook challenge. Reach out to me and I will send you your DLI voucher. There we go. Any other questions? Okay, we have Andrew saying, finishing my PhD in computer science, computer vision during the pandemic, non-ML based. Been skilling up during my jobs and learning as much as I can. Been prototyping ML related things in TensorFlow, PyTorch, and FastAI. When the competition was 2 weeks long, I knew I had to go FastAI or rapid training prototyping. Oh, that's cool. So FastAI was kind of a choice based on how quick the competition was too. Just like the name says, you can kind of iterate over things quickly with it. So when will the next PogChamps come out? I don't know yet. We will know. We will find out soon. When I find out, I will let you guys know. Great work. Awesome job, everyone. Claps. Claps for chat. All right, you guys ready to change gears a little bit? Close this. So I have been doing some more analysis. All right, so we're going to switch gears now. If you don't know the background behind some of the stuff we've been going over previously in stream, there has been some drama in the chess world. Clouded Spirit, welcome to the family. Thanks for joining. Let me know in chat how you found us. So there's been some drama in the chess world, and there's been some analysis out there over potential cheating. I don't know if you guys saw in the Wall Street Journal, there was a new article that came out just today about this. So this guy, Hans Niemann, a U.S. chess player, beat the best chess player, Magnus Carlsen, in an event last month. And out of that came some accusations, direct or indirect, of potential cheating. And also since then, a lot of people have pointed to different data sets that supposedly prove that this guy's cheated. Now, he admitted to cheating in games online, but not in games. He said he's never cheated over the board, so in a real live tournament. Now, in this exclusive that came out today, and I think this report came out, so I don't have access to the Wall Street the Wall Street Journal version of this, but there's actually a report that chess.com just released that kind of contradicts what Hans said, how much he cheated. So they're saying he cheated in over 100 games, many of which were for cash money. Hey, Baby Washroom, welcome to the channel. Andrew Spears, you have Discord, been trying to do ML and seem very knowledgeable. Yeah. Hey guys, by the way, !Discord. Let's find our Discord channel. If you want to join my Discord, maybe you guys can connect over there. I'll put the link in there if anyone didn't get it already. Please feel free to join. We would love to have you. So there have been some allegations that have come out about over-the-board chess results, both by chess.com, kind of indirectly, and then also with other people releasing their YouTube videos and analyses out there. So we were trying to see, okay, if we are going to find a chess cheater, how would we do it using just the data? So let me open up VS Code here and talk about some of what we've done so far. Some of the data showed Hans had 100% accuracy, which is impossible. Yes, so that's what we looked at last time. Engi, I hope I'm saying that right. Welcome. Also, great job on your work in the competition. You had a great notebooks, and I really enjoyed your how active you were on the competition that just ended. So, yeah, that analysis that showed that Magnus, and I think we looked up the YouTube video before. We were watching through it. Has been disproven. So that analysis relied on ChessBase for the amount of accuracy that they were giving Hans Niemann for certain games. And that was, I guess, doctored. So I'm sure I can find the post here and we can talk about that. So basically what that had shown was that for some of the games that Hans was playing in, they showed 100% accuracy. And I was actually writing this code in order to not disprove that, but to double check it. And it's been kind of disproven since then. And we were not seeing 100% accuracy when we were running this analysis on the games that they said that he was doing. So let's see. I thought this was pretty interesting. So putting this all in context, the Reddit chess subreddit, this is what people on the Reddit subreddit believe about what Hans has done. So most don't believe that he cheated in the Singfield Cup, which is the event that Magnus Carlsen left after playing and losing to Hans. And then it's kind of interesting how divided it really is in terms of what people think, at least on the chess subreddit, which I don't know is like a good sample population, but it's a population nonetheless. The thing I wanted to see though was wow, there's a lot of infographics. Ooh, this is another statistical analysis of Niemann's centipon loss. So this is kind of what we're getting at. We're going to be looking at the centipon loss stuff. This is a Brazilian scientist who kind of went into detail about his analysis, which I guess came out a few days ago and goes in line with what we're looking at. But I think some of his conclusions are a little bit stronger than what I would say. So what this guy has actually been doing is, all right, so let's start out here at the top level. So what even is centipon loss? So there's no like clear definition unless you're in the very end games where it's been theoretically proven what the best move is, but it's very hard to determine in any given position of a chess game what is the best move you can make. And all you have to go off of is what the engine says is the best move. But if you make the engine run deeper or longer, and we're running this, I'm running Stockfish 15 here. If you make it run longer or with more depth, it may find that another move is better. But what centipon loss is telling us is, at least based on what the engine thinks is the best move, how many pawns of an advantage does one side or the other have after the next move is taken. So let's actually look up centipon loss to make sure we know it. It's a unit of measure used in chess as a representation of the advantage. So if you're playing a game on chess.com and you see like a +1, that's you're up a pawn. The engine is saying that white is ahead by a pawn, right? A centipon is equal to 1/100th of a pawn. So when we're talking about centipons, just divide it by 100 if you want to see the amount relative to a pawn. These values play no formal role in the game but are useful to players. Top computer move will lose 0 centipons. So that's assuming that the top computer move is the best and like alpha 0 doesn't beat that computer or whatever. But lesser moves will result in a deterioration of the position. The value may be used as an indicator of the quality of play. So think about it this way. If the best engine has a 0 centipon loss, if you also play the best move, then you have 0 centipon loss based off of that. So what does our code do? Let's step through it again. What I've written this code to do is, number one, we can download let's find this new repo, chess cheating analysis repo that I created. So I downloaded all the different Grandmasters games using this PGN Mentor website, which has a zip file full of the PGN, which like represents all the moves from their games. So we can actually walk through, or sorry, not PGNs, PNGs of their games. Then I created a script that took these PGNs and converted them into kind of an easy to read data frame format. So let's actually walk through that here. I know I'm jumping all over the place. Let me know if none of this makes sense, or if you guys want me to slow down. Are you continuing with your chess cheat analysis? Imposter engineer asks. Yeah, I'm trying to. It'll take a little bit first, a little bit forward. So there's that high level analysis where they've taken the centipon loss and you can look at like an average over your entire game, what your centipon loss is. And then you can also look at your specific cent upon loss for each move. And then another thing you can look at is the player's rating compared to their cent upon loss. So that's one of the things that kind of came out with this new video, was this guy was looking at close this. People have been looking at the cent upon loss versus the rating of the players and making some, I guess, making some assumptions about if you are a certain level player, you should have this correlation between your average cent upon loss and your rating. So this is a very clear example where I guess across all of the players, it's this straight correlation. That doesn't mean that you can't deviate from that and not be cheating. Were you able to verify some of it? So Imposter Engineer, what we found was that prior analysis where the person had released all the accuracy of each of Hans Niemann's games was actually corrupt. And that's why we're seeing so many games that showed 100% accuracy. And when I try to recreate it with my analysis, I could not actually find the same results. There's some weird stuff going on with chess base, apparently, that caused those results to be incorrect. But what this guy is doing is kind of similar to what I was looking at, which is actually analyzing the cent upon loss by running your own computation of the player's moves versus the top engine move, or the cent upon difference between those moves. Because if you actually just look and see how many times the best move was picked, you can actually win a lot of games and not pick the number one top move. You could pick the second to top move and it'd be almost as good as the top one. So you kind of want to compute that for each move, what the cent upon loss difference is. Are there any beads recognized during the calculations? Nope. No beads recognized. So what this guy is showing is a bunch of different players, their correlation here. And then he gets to Hans, which is kind of interesting because he's first showing that up until 2018 that there's the same correlation that you kind of see for other players, right? Raphael Milk, you know who this is? Milky Chess, yeah. But then when he adds in this other data point, now granted there are 4 data points here. Like, you don't expect this to necessarily always be correlated. Let's say if you had a 5th data point that was down here at 45 and he was 2,700, right? Then maybe you would start to see actual correlation here. But with 4 data points, it's pretty sketchy to kind of make some conclusions here. But the statement that's being made here is because this correlation is not here, that obviously he's a cheater. Now, I think this is a little bit too broad of a statement to be making, and you'd have to actually see this for a bunch of different players to actually make that as a statement that I would be able to stand behind. How would that even work? He's supposedly without any actual nerve endings to have any reaction. I think that whole beads thing is just a funny joke. Yeah, I don't know if this is good enough for me as analysis to say that for sure he cheated. So I've been running this in the background, and I'm going to go ahead and stop this, and we're going to walk through this code that I've been running in the background. So you haven't been noticing it, but my computer's been hard at work actually running analysis on all of the games from the Singfield Cup. Now, my plan is to ramp this up to more games, but we're going to look at exactly what I'm doing in this code here step by step. So we have, let's just go here. And step through this code. So what I have here is, I was just saying PGN. Oh, I need to import this up here. So I have downloaded this Singfield Cup 2022 PGN file, which has each of the games. Stockfish for Python. Nice. Yeah, this is Stockfish in Python. So this Stockfish, you could actually use using the Chess API, or you could just use Stockfish directly, and I'm using Stockfish directly, and I'm linking it here to my Stockfish 15 version, which I downloaded and built here on this, on my operating system. So it's good to go. Run this. Then I'm going to run my little script here that converts all these PGNs into a data frame format. We're going to see what that looks like. It happens real quick. And then we now have, instead of, and I keep on saying PNG, I think, so forgive me, but PGN file converted into a tabular format where now we have the player's name who's playing black, their ELO, this is the opening that was played, the result of the game, the round numbering, which is actually pretty clean in this format. And then this is what we care about, the mainline moves. So if we go to mainline moves in this data frame and look up this first one, these are all the moves in the game between Wesley So and who's playing as white? Oh, that's way over here. Mehmet Darvel. So this is this game, and we could see the mainline moves. Then we can actually load this into a game board, a chess board, which would look like this. And we actually have this board, which we can then step through all the moves of. So in this position, opening position, we could run Stockfish here, but it's pretty worthless. Then we could do for move in board.move. Oh, mainline moves. So basically what we can do through here is we're loading this main board. Then we're going looping through every move in these mainline moves. And we can break after this and actually take this board and push this next move. Now, if we look at the board, our new position has this first move done. I was reading PNG instead of PGN, and I was wondering how you would use an image. Yeah, it's a little confusing, Mr. Gabriel. I'm getting confused myself as I do it. But you can see we could use this board object to actually push the different moves. And then from here, we can get the FEN notation. The FEN notation is actually showing us all the position of all the pieces on the board. So it's like the same representation of this image version, but the FEN can be fed into Stockfish. Stockfish is one of the strongest computer engines out there. So we can take this FEN and create our Stockfish. Before we do this, we have to create our Stockfish object. when we create this object, there are a few things that we have to set. So the number of threads that we want our computer to run. You could see here, my machine has 64 threads that we could be using. I am also streaming right now, so I don't want to use all of them, but I think 32 is fine. And then minimum thinking time, might not need to actually set that. I think it defaults maybe to 30. We want it to go faster if it doesn't actually need to think about a move that's an obvious move. And then this is the big one, the depth. So the more that you increase depth, it's not a linear relationship with the amount of time it takes to run. So a depth of 10 could go pretty fast. 17, depth of 10, I think would take like on this machine 20 seconds to maybe go through a whole game. A depth of 15, maybe 2 minutes, 17, maybe 4. And then when I was doing 20, it's like 10 minutes to run. Pure Electricities. Yeah, it's a decent machine. I built this myself a few years back. So it's held up over the years. So yeah, let's actually set this depth to be pretty low. And then we can show that with this stockfish object, we can set the FEN position to, let's call this the FEN. Now our stockfish, can we get the, if we get the FEN position, it's this, which we could then load into our board. I think we load it this way, right? Let's not worry about that. Just take my word for it that we loaded in this FEN of this position. And then we can get the top moves. So by default, this gives us the top 5. And I want to have it give us the top 10 moves. Now, granted, this is a depth of 15, so 5. So yeah, let's do this. Let's just see what the timing is. To run for a single move with a depth of 5, we're going to run time it on this. So time it will run this a bunch of different times in a row, 7 times or so. Ashay, thank you for your positive words about the PogChamps competition. I had a lot of fun. We had a lot of fun reviewing it today too. So if you want to go check out that, let me know. What's FEN? Southern TW says. FEN is actual notation for the board setup. So if you think about PGN, portable game notation, PGN actually walks you through an entire chess game with each move that was made. So it's saying like, these are the moves in order starting from a certain setup. You also have some metadata in it, like the who is playing as white, who's playing as black, the date, etc. FEN notation, Forsyth Edwards notation, lets you set up the board in any position. It could actually be a position that's not legal to make, to have in chess, because you're just telling for each of the rows in the board what piece should be on each position. So lowercase, I believe, are white pieces, uppercases are black pieces, and then these 8s are just saying that those rows are blank. Someone else said, depth is how many moves ahead Stockfish engine is looking. More depth. Yeah. More depth equals more variations of the game. So let's see if there's like a good image of it. Think about this as like a tree that it's looking in. Hey, Tuan Fivu, welcome to the stream. Hope you're doing well. Let me know in chat how you found this. Is theory to compare frequency of all players using center paw loss on all moves if a cheater only chooses to use the engine at one or two difficult points in game? Good point, Matt. That's kind of what I want to look up. That's kind of what I want to get at. Seems like your data might be drawn up by all the easier movements to assess. The center paw loss for move does not equal Y. Yeah, the other thing to keep in mind, and also welcome to the family. We had someone join. I missed who it was. Spiked Punch Man, welcome. So yeah, we want to actually see what the Centipon loss is at certain moves. Also, if your Centipon loss is low in a move, but it's forced, you got to consider that too. Like if it's a forced move, or if there are really no other options other than that one best move, then you might pick that move and not necessarily be an indicator of cheating. So this is a lot of complicated things going on at the same time. So yeah, this is like a maybe an easier way to kind of compare what depth is, like the number of simulations or situations that it's looking into depends on a few things, but depth here is like how deep down into moves is it going to look to see to evaluate who is doing better. So you can imagine these trees, as your depth gets larger and larger, this grows into a huge amount. And that's why as we increase our depth here, we're going to see that it's going to become slower and slower. Okay, so about half a second plus or minus 40 milliseconds per run to get the top 10 moves at a depth of 5. Now let's run it at a depth of 10, excuse me. Number of children in binary tree? I think so. I think kind of like that. I'm sure Stockfish does some smarter like pruning of the trees. There are certain trees that you might go down that are obviously lost situations, which you wouldn't actually go and see the full depth of, but some sort of representation of that. All right, so then we ran a depth of 10, 641. So actually not that bad, not so bad. Now we're doing a depth of 15. Granted, this is only evaluating one single position of the board, one FEN position. If we do this for a game, we'd have to run this on every single move. All right, so here you can see our depth went from 10 to 15, but our time it took doubled or more than doubled. So this not linear relationship, and then we're going to go to 20 here. It's going to take a while, little while. And while that's running too, I can show you here. These are all like, this is the processing done under the hood. If we had just like your grandma's laptop running with her 2 CPUs or 2 threads, this would not be running as fast. So we definitely have some manpower going behind this. What's this project about? Spiked Punchman. We're trying to do some analysis into chess cheaters. Chess cheaters. Because that's kind of the hot thing in the chess world right now is who's cheating? Who are the cheaters out there? Are you on Linux? I am, sir. Yeah, this is Ubuntu 2004. I need to upgrade to the latest Ubuntu. All right, 5 seconds plus or minus here we have for going up to that new one. Hey, welcome to the family. We got a new person who joined the fam. Sarah Connor, welcome. 1959. Sarah Connor, that's a classic name. Love it. Are you from the future, Sarah? What's the depth someone like Magnus uses during his gameplay? Is it possible to pick a number there? I don't know. I was actually thinking of the same thing. What's the maximum number of chess moves in a game? It's more than the number of atoms in the galaxy or something absolutely insane. Something you could never, well, at least with technology nowadays, something that's like completely out of the realm of possibility to run every single one of every single game. Now they have these end game databases where they have run every move and proved who's winning in certain end game situations, but that database like is everyone working trying to figure them out, and they're very simplified positions. Hello, this is Manish. Happy to join. Welcome. Thank you for joining us. We're trying to check out some chess data analysis. Do you know zero knowledge proofs? I do not. I do not. Sarah Connor, you are from the future. I've heard it would be more like 10 to 90 years to calculate one game from beginning to end. To calculate one game. Oh, to calculate all the potential. I don't know what that means. Because you couldn't, if you calculated the true cent-upon loss at the beginning of the game, like the first move, then you've solved the game of chess. Which I think is almost impossible. That's why you have to set this depth to a reasonable number. I didn't mean potential moves, didn't know whether there was a finite limit actual moves taken. Oh, okay. So, Lopta, you mean like in the first move in a game, there are only a certain number that you could make. In any given situation, I guess there's like a certain limit. I think endgame they solved up to 7 pieces. Oh, okay. Lopta meant something else. Okay, you got to explain it to me in the chat. Okay, so what is this code that I wrote, this game engine results doing? All right, so some things to note. I wrote this code so that you could set the first evaluation move to be something other than the very first move in the game, because let's assume that grandmasters have prepped going into the game up until a certain number of moves. Like I play E4 or E5 as my first move. I would guess a grandmaster has an idea of what they're going to play next, and they're not actually calculating it. They've planned out what the response is going to be to that before the game, right? So we're basically just going to ignore the first number of moves. A better way to do this that I want to do eventually is to actually look in some of these opening databases and ignore all the moves up until the known opening is over. So if we look at this data frame with all of these games, this first one with Wesley So, the ECO is D41, which is the Queen's Gambit declined. Oh, that's dark mode is not working on that site. So basically getting up to this position is like a known position that you don't really need to analyze. And this actually goes, what are these moves? These are all the games with them. But this goes up until move number 5. So maybe I'm going a little bit too far here, going up to 10, but I'm kind of letting this be a variable that you can set. Then what are we doing? We're loading in the game, and then we start iterating over the moves. We're setting the Stockfish FEN position. Then we're picking out the top 10 moves, and I'm storing them into this data frame. This data frame is storing the top 10 moves, what they are, and what the cent upon loss is for each of those 10 moves. And then we're also doing this check for each of these 10 moves. Is the actual player's move equal to one of those top 10? And if that's the case, store what rank position that they picked, or one of the moves did they pick, and what's the new cent upon loss there. Mr. Wolfred Stepp, welcome to the family. Hope you're doing well. Hope you're doing well. Need to find a better music channel. I hope I don't get, I always get blocked for using this music. Hey, Prep 56, welcome to the family. Hope you're doing well. Let me know in chat how you found the channel. I'm doing well, Mr. Wolfenstep. We're just checking out some game data, chess game data, trying to find some cheaters. DRM free. Discord link, ! Discord will give you a link to my Discord if you are in Twitch. Otherwise, I will just type it right here. I don't know if it comes up on the YouTube chat, but I can put it in there for you. Okay, so yeah, so this is what we're storing. And basically we have just a data frame here at the end with each move number. I guess it's not called a move. A move would be like, this should actually increment when white plays and then black plays, and then it increments to move number 2 and so on. But I'm just using this as move number is equal to, yeah, the ply, I guess, the ply. Then I'm doing this just to save the results. And let's do some analysis of the results. So basically what I did was I started running this earlier today and I didn't get that far through it. This was running during the beginning of our stream, but I was running through 38% of the games in this 2022 Singfield Cup. Hey, Kamindev, welcome to the family. Let me know in chat how you found the channel. All right, so this was running for 1 hour and 34 minutes. We could run this on entire player's history and get some of the analysis from it. But then what I was plotting here was basically what was the centupon loss of the best move versus the move that the player picked throughout the game. So you can see here that there tends to be back and forth in certain parts of the game. There's also parts where both players are actually picking the top engine moves. And this isn't that surprising if it's kind of an obvious end game, right? How much data science do you need to know before machine learning? I think they come hand in hand. 7 deadly sins. 7 deadly sins. Yeah, I think you just take it one step at a time, and machine learning probably would come after you're confident in your coding abilities and you have some understanding of, stats and linear algebra. Check out my YouTube channel where I have a video of how to get into machine learning. I actually have a whole video on this. If he cheated, how did he manage to do it? That's the big question. So there are many ways you could think of that someone could cheat. So almost limitless, but I personally don't think he actually cheated in the live games, especially not the ones at the Singfield Cup, given all the extra eyes that were on him after the accusations. Hey, welcome to the family. We got a new follower. Adrian Nuzirazar, welcome to the family. But hey, people are pointing out, and chess.com released a report today, or at least there's articles out about this report, where there's some more analysis showing over the board that his rise is kind of been kind of crazy. Exa20, welcome to family. Let me know in chat how you found me. All right, so we're gonna import pandas. Let's actually, in the last like half an hour of the stream, have you had a chance to see a chess.com document for their fair play team? No, what is that? What's the document say? Is it anything? I would imagine it just says you don't cheat, right? You mean from the motherboard? What from the motherboard? What am I missing here? Okay, let's do some coding. Pandas. So I've run this through, not all the games yet, but 15 of the 40. And I was saving the results here. I'm crazy here. I don't know if I spelled that right. I knew I spelled it wrong. Singfield. We're going to list out all the games that I've processed into this data directory. And yeah, these are all the Parquet files that I've stored my results into. So let's go ahead and read one of these. Read the Parquet file. Singfield Cup. Let's pick a more interesting game. Let's look at Carlson Nepo, first game of the tournament. Let's also read in this metadata like I did here. This is like our metadata about the games. All right, so with this, what this will show us is we can actually look at, hey, welcome to the family. No, Matt. We can actually look at, hey, how close are we to getting to 2,500 followers? We're close. 75 away-ish. Less than 75. So did I store each of the players' names here? I thought I did at some point. I'm also saving the Stockfish version and the depth that I'm running in. And then this is the difference between what they played and the engine amount. The engine sent upon loss. So, welcome to the family. We got someone, Bugs Bunny. Welcome. That's all, folks. No, that's not all, but saying that for Bugs. This is good. Why don't you start a Twitch account? Me? I have Twitch. Join us over on Twitch. I'm streaming to both right now. And Maya is saying that on YouTube right now. Too long didn't. They are highly confident he cheated 100+ times online, much more than he admitted to. Yep. But do not say for sure he cheated over the board. They also are very hesitant to say anything about overboard cheating. That's in Fide's domain. But they also kind of alluded to the fact that even over the board, he has one of the highest rises to the top. I did talk about Bugs Bunny. I did talk about Hikaru's recent videos about it. I want to make a video that's good enough that he'll talk about on his stream. But I need to kind of make all this stuff concise. Concise, right? Hikaru also likes to talk about the dramatic angle of all this too. And the most dramatic angle is believing that something crazy was going on. Like he did have beads. So we're going to say the round equals 1.1. That's this first game that I'm pulling in. And this is Wesley So. Oh, this is 1.4. This is Nepo playing as black. Color. And then we're going to map this as Nepo. And we're going to map the white moves to Carlson. All right, so for this game, which ended in Nepo's win. Is that right? 1-0 means, no, in Carlson's win. Hey, Guns, welcome to the family. Hope you're doing well. Those analysis legit, in my opinion. We were just talking about that. We were looking at this, and I was saying, I think it's a little bit too simplified of a way of looking at it. So the one thing that you'll note is that he has, for his analysis, he's looking at kind of a simplified version of what we're looking at, where he's just averaging the centupon loss at a player's over the board rating. And he's choosing these steps based on like these big swings in rating numbers. For most players, you have a lot of dots. More dots, well, this player you only have 4, but more dots gives you more chance to have kind of a linear correlation. When you only have 4 dots, it's pretty hard, especially when you have 3. It's hard to say if there's a correlation. You draw any 3 dots, and you could probably find a line that can connect those 3. I mean, not necessarily, but so then he's showing this as like the main analysis to say why Hans Niemann cheated, because his correlation between the rating and his centupon loss is actually kind of stayed the same as he jumped up the ratings, which would mean that he's accusing him of cheating here early on. This doesn't really make that much sense to me, how this would be true. I also don't understand. Here's something that doesn't make sense to me. Oh yeah, he's doing some kind of sketchy. This is really sketchy, actually. I didn't realize this at first. But look what he's doing. He's cutting off from 2,000 to 2,200. And there's this linear correlation. Then he's splitting out these 4. So he actually has 7 dots to try to draw a correlation line through, which actually would probably appear if you showed all 7. You probably see a high correlation, or actually more correlation. But then he's taking out the back 4 and showing how the correlation doesn't exist there. I don't know about this. That's really sketchy. This is kind of random. What keyboard is that? Aaron asked. This is just a DAS keyboard. DAS keyboard with the brown keys. Oh, and I just hit F1 there. All right. So for this, what are we going to look at? We're gonna group by player. All this is to say we're going to group by player. Then we're going to look at their played engine centupon difference. So what this is what's the difference between what they played in the top engine move. Diplomat, great. Welcome to the family. Hope you're doing well. And we're going to plot this as let's do a horizontal bar plot. For player D, and let's group this. And let's make 2 plots side by side. I accidentally. And then we're going to do an index location. And here. Okay, so hey, Dr. Hobby, welcome to the stream. Let me know in chat how you found us. All right, so this is basically showing their worst move is going to be a bigger bar. So a bigger bar means a worse move. Let's make this width a little bit higher. And then should we sort it so the game starts at the top? No, this is fine. And then let's go to title is player. All right, so on the left we have Carlson, and on the right we have Nepo. Did Carlson lose this game? Carlson lose? Let's go ahead and we can throw this in the PNG. Hey, welcome to the family, Tool Shed. Take you out to the tool shed. All right, so let's take this metadata and let's take the moves. Mainline moves. And let's just throw this into chess.com's evaluator to make sure that we're looking at this correctly. Paste PGNs. Got a little bit of quotes in here we got to take out. We did this yesterday. All right, so here's the game. White is Carlson. And let's run a game review on this and see what it says. Let's compare our results with what we see here. So what we are going to say is, let's try to compute our own game accuracy from this standpoint, using the cents upon loss versus Stockfish with a depth of 17. So we're going to query where the player equals Carlson. And he's playing it as the white pieces. And yeah, he did win this game. He actually had a 95.3% accuracy according to chess.com. And black had an 89.6. I would like go crazy if I had, and this is running at a depth of 17th, so a little deeper than what ours is running at. I would be ecstatic if I had a game that was this high. All right, let's see what you guys are saying in chat. Cherry MX Brown is nice if clicky choice. Yes, that's it. That's it. The Cherry Brown. Wasn't the implication that he started cheating post 2500 rating, and that's where the correlation? Yeah, I mean, I think that's the after the fact accusation, because the data maybe points to that. So it's always the question of, are you letting the data drive what you're saying? It's limited data, so there's going to be some abnormalities. And if you just look at any player, can you pick a point where you can cut and find the optimal point where you can kind of prove that there's cheating after that point? I don't know. Maybe you can. But it seems a little sketchy that you just arbitrarily choose when you think he started cheating. Because he did say he cheated online, and they showed that he cheated online back when he was 12 years old. So why wouldn't he cheat over the board back then? But yeah, I guess that's when he said he focused more. He got kicked off of chess.com. He said he focused more on the others, on playing over the board. That could also be why his cents upon loss started to dip way down, and maybe that it just took his rating a while to match up with his true abilities once he started training more for over the board. I don't know. I plan to use the account for cheater's opponent making a blunder. Using this to account for a cheater's opponent making a blunder. Mainly just looking at how well that player plays the games. At least at this level, GMs don't really make that many blunders. It's more of like using small better moves in the middle game to get a better end position, at least the way I know it. Better end game position, and then incrementing from there. Hi, a new viewer here. Was curious about your career path. I graduate next May from ComSci and curious about data science. Great question. I actually answered this one on Nick Wan's stream a few days ago, and he's going to have a podcast out for it. So be on the lookout for that. But yeah, I've taken a long career to where I am now. And if you're at the beginning of your career, you have a lot of fun to look forward to in computer science, data science. There's a lot to do out there. I love what you're doing, watching your videos about a week. You articulate data science in a way I've never seen before. Oh, thanks, Fighter Jet. Appreciate that. Sometimes I feel like I'm speaking nonsense, so I appreciate it. All right, so we're going to look at Carlson's. Now, one thing to note, there are situations here where the centupon loss is null because Carlson's move, let's look here, on move number 61, which I'm realizing here should actually be 30. Maybe 31. He did E8 to E7. I don't see any E8 to... Hold on here. He played E8, E7. Move 61. Which should be 31. Am I actually looking at... Oh, so this is looking at Black's moves. I'm realizing something here. This is saying it's the white pieces, but I think that my code must have a bug in it because move number 11, I think I wasn't accounting for the fact that move 0. So these are actually, this explains a lot. This explains why my plot didn't look correct. So these are actually flipped. Carlson is playing the white pieces, but I have it mislabeled here. So maybe a better way to do it would be to invert this. Color to move, I think. Or just, yeah, for time's sake, invert this. And now this plot makes a little bit more sense. So yeah, Nepo was starting to make all these endgame blunders. Move number 60. Yeah, so if we actually look at Carlson's now, and let's actually see if this, yeah, so this question mark, if you go to the analysis at this position, he moved rook E8 to E7. And it's showing that this is not in the top 3. I think I can even show more lines. Number of lines, 5. It's probably not going to be in the top 5. So all these moves are pretty bad, but this move isn't even in the top. So I should actually fill those in for where the move is not in the top 10 as being like a minimum, at minimum, worse than the 10th move that the computer is showing. But it could be even worse, even more worse than that. Okay, so let's look at this difference of the played values versus the engine centupon. So this value doesn't tell us much. Like the average value is 8.3. Leo Bio Info, welcome to the family. Hope you're doing well. Actually, let's also look at this guy's. He has a Canva documentation on this. I want to actually see the data he had to see if I could double check this. Black Blaze rookie 7. Not sure what that means in the comments. So let's say, what percentage of all of these moves is this difference less than 10? I don't know. This is just one way to do it. And then this will give us like a value of 72. So like, it's kind of hard to say. I guess if the Centipon change is less than 50, but that's still like half a pawn off the best move, it would give us Carlsen's accuracy is 97%, which is what this game review shows. 93, 95. Let's see the exact same thing for Nepo. It's giving him a 94. So part of it is it definitely is showing that Nepo played worse. Carlsen said better, but I'm not sure exactly how they get to this number of the accuracy. Clearly it's between 0 and 100, but are they saying like, if you had, yeah, I mean, you can compute as the difference over the number of moves, I guess. Just join. Are we doing an analysis of the Carlsen-Niemann game? Yeah, Amir, we're trying to get to the bottom of using data, how we can do an analysis that shows us potential for cheating in chess. And one of the things I kind of want to get at is, I think what we need to look at are when these spikes occur and do they actually occur? I think for often. And the spikes show how any large bar shows on that move that the player actually was way off from what the best engine move was at that moment in the game. So it's hard to see here too because the scales are different, but Nepos are a lot larger than Carlsen. So let's actually put can we do share Y? Yeah, it'll be a little, set Y range, set Y lim as a 0 to the max value here. Oh, I should have done it X. Oh, we need to actually take the absolute value of this. Abs max. And we need to do from the negative value of this to the positive. What this is giving us is this will make these plots on the same scale per player. Okay, so here's the interesting thing. Before I was actually showing them where each plot was kind of scaled for the player, but now we could see actually when they're both on the same scale how much larger Nepo's mistakes were than Carlsen's. So question is, how do we quantify this in a way that gets sort of close to this accuracy that they have? Accuracy number is aggregate of the difference from the top engine move, Amir. So I have that data here, which is this played engine centipon difference. Let's do it for Nepo. Now the mean value here is negative 21. So the question is, how do we put this in a 0 to 100%? I guess we could do this by the number of moves. Hey, Dr. Fade. Welcome. We could do this by... But that's kind of weird. So that's saying for Nepo that he averaged half a pawn of loss per move. It seems like a big swing. And Carlsen averaged 0.22. The challenge we run to with overboard and cheating is that the top player only needs to be given the best move in a few critical positions rather than every move. Correct. So what I kind of want to get to eventually is run this on all these games and then basically see if there's any trends to when these spikes in playing far away from the best engine moves are less frequent, or if there are certain positions where, like moments within the game, where certain players like Hans Niemann have less spikes here. Maybe that will point to the fact that something sketchy is going on. Maybe it's just pointing to the fact that he's better. It's hard to say. So here's a Niemann game. Hey, Eshinin, welcome to the family. So you can see... Let's look here. In all these other games, you kind of have spikes more than 40. I guess not MVL's game. And Caruana's game, there's some big spikes, but most of this game was like they're playing the top engine moves. Niemann's game, I don't know. It's hard to say. Like, maybe he has less spikes. I don't even know if he's the blue line here. It's kind of hard to see. So let's actually load that in. Let's load in one in Niemann's game. Community Theory learn the best engine moves by playing against engines almost exclusively. I think the engines just know too much. There's no way that you would ever learn as much as they do. Hey, new here, Eshin says, learning HTML, my first language, going well. I'm a noob, though, so here to learn and lurk. Well, hey, welcome. So glad that you're here with us. It's awesome. We're just looking at some chess data, trying to get to the bottom of cheaters in chess. Yeah, it's basically impossible to say, hey, you just play against the engines and you're going to be perfect. But at the same time, there's some truth to that, right? Because newer players actually, they're saying, have been able to adapt to the game a lot better because of use of engines, because they can kind of use it to their advantage to find these positions where they can like memorize opening theory to the point where it reaches a new position that their opponent may not be familiar with. And I definitely think that's ways that they're leveraging engines at this point to become better at chess. But in terms of just like playing against the machine only, I don't think it necessarily works that way for like a human brain to become the best chess player. But what do I know? I'm pretty horrible at chess. That's what you mean? Yeah. So I don't know if like playing against engines is necessarily the thing that they use to get as strong as they are, or it just helps them in their preparation for the games. Okay, so Carlsen Nepo game, interesting kind of. Now let's look at one of the Hans games. Meta. Actually, we'll look at over here. Our data. So you can feel comp. Let's look at the game in question, the Carlsen Niemann game. 3.1. 3.1. Hans is playing the black pieces. Carlsen's playing the white. Maria, welcome to the family. I'm so glad to have you here. Let us know in chat how you found this channel. That would be awesome to hear about. So we're going to pull in this data frame. We are going to run this plot. And remember, it's flipped because I had that bug in my code that we're just going to deal with for now. But because it's flipped, Neiman, we're going to say here, and Carlson. Carlson was actually white in this. Huh. So is this saying that Hans actually was doing a lot worse in the end? Do I have this flipped? I must have this flipped. Yeah, so let's look up this game. And look at the main line moves. Actually, we could actually read this. PGN file. Look for 3.1. And load this game in to here. Analysis board. Analysis PGN. Yeah, so if we do the game review here, we can kind of see what they're going to say. Oh, look, I can share this review in the chat. So it seems like Neiman made better decisions later on, which would agree with my hypothesis that he memorized engine moves. Maybe. So Carlson had 86.5 accuracy. Neiman had 91.5 according to this. This is saying 30 best moves. And let's just double check these numbers. At least we can double check these numbers. In this data frame that we opened, oh, this is why I opened the wrong one, 3.1. This should be 3.1. All right, this is going to explain a lot. All right, this is explaining a lot more. Now we can see actual Carlson having bigger swings, much bigger swings, especially at the very end, and Neiman still having some swings. And like, this is the crazy thing, is look at. In this game that Neiman had against Carlson, he did still have some moves that were like 2 pawns off of the best move. Negative 200. Granted, these are moves that probably only the engine can see. Be very hard for a human to actually see. But if we go back here to like the Carlson Nepo game, Carlson didn't even have any moves that were greater than 100. Remember, bigger numbers are bad here. That means worse moves. So Carlson actually played better in this game against Nepo in his first game than Hans did in theory against Carlson, which is kind of interesting to see. Now, I don't know, like, how would you see if these moves are necessarily in combination as bad as it? Like, is Neiman cheating because he actually didn't have any bad moves all the way up until 71? Or I mean, I don't know. This also was a longer game. Something to keep in mind. This game went 112. So, yeah, like 60 moves. Let's see here. Yeah, 57 moves. So I don't know if that plays into it too. let's see what, so I think what we have to do here is actually run this analysis on hundreds of games for a bunch of different players. So picking a bunch of different games for recent over the board tournaments, running this analysis, getting the set upon loss for each game, and then trying to see if we can identify cues that would point us into when a player may or may not be cheating. I have a few ideas for how we could do it. That could be fun. Maybe I could play some games against the computer and see how often I'm cheating. If it can detect that, if I could play like 10 games where I don't cheat, 10 games where I cheat every so often, and then actually just have 10 games where I pick one of the top 3 moves and see if we can kind of detect what that looks like. I think it should be pretty obvious. Does this normalize for opponent skill? No, because this is completely Valfer. This is completely independent what your opponent does. It's just evaluating what your best move is in a given position. Because at least these grandmasters don't play for those like silly tricks that those of us lower players can fall for. So yeah, sure, they may be setting up longer term traps, I think, but in general, they're just looking to play the best move they can at any moment in the game. Like not doing, I mean, they may be sacrificing in the opening for a better position or something, but that should in theory be accounted for in the computer's computation. HHT Woo, welcome to the family. I hope you're having a great night. Thanks for joining us. Hey, thanks to everyone who's kind of hanging out with us tonight. I know that I've been kind of rambling on, getting very far with this analysis, but at least we're learning some stuff. HHT Woo, whoa, you just came out of nowhere and then subscribe. Thanks. Let's spin the wheel and then we can end it on that. That'll be the last thing we do tonight. Thanks for hanging out, everyone. Do you have any questions for me? How do you remove bias for positions that all players know well in the mid and late game? Are there positions that people know in the mid game? Oh, I spin the wheel and it landed on do nothing. Lucky me. So I spin the wheel every time I get a new subscriber on Twitch. You can use Amazon Prime to use a free subscription. It doesn't cost you any money if you link that to your Amazon account. And do that. But thank you so much for the subscription, HHT Woo. I wish you would tell me. Do nothing is unfair. Do nothing is, what are the odds of do nothing? The odds of do nothing are very low. Now, if you were a skeptic out there, you would say that I've cheated and somehow, like Hans Niemann, I've manipulated this whole game to spin on do nothing. But I will attest to the fact that this is just luck that it landed on do nothing. If you watch my stream at all, you've seen that it lands on the other stuff a ton of times. So I typed pizza 100 times today. Some beads going on for sure. Mid game, if it's in their play history, I guess. I think once you reach the middle game, Matt D, that like by definition means it's like positions that the players haven't memorized and they actually have to start calculating. Or their opponent's history, which I probably study. Yeah, I think that's the opening theory that they would have studied. You knew when to click spinner. Yeah, I just clicked it. So game plan here. Run this. I have this code that's able to run. Then we have this data that we can do analysis with later. First thing is just processing a bunch of games. So running all of Niemann's games, all of Carlson's, maybe even double checking it against some of these other people's databases that they have. And then trying to see if we can draw any conclusions as to the level of play. See, I think it's a little bit oversimplified to look at the average cent upon loss and the rating, because this may be showing that like the rating is just a lagging indicator of how well the player is. Let's say if like Neiman got really good at playing and then never didn't actually play any over the board rated games for a while because of something like COVID. And then after COVID played a bunch of games and his over the board rating caught up to what his actual skill level was. That, I mean, I'm not saying that's the case, but it seems like that might be one explanation for it if you believe that he did not cheat. So we need to do a little bit more looking into it. And I think that if you're going to make these sort of accusations, you have to actually go into the games and show me, okay, which moves then are moves that he should not have been able to calculate. Can we look at all of Neiman's say in the past 2 years and see how the correlation versus the top 3 engine moves versus Carlson's or other top players? See, HHT, I think that's the problem, is that the claims are that you can just use the engine at certain times in the game, like 1 or 2 moves. And that could be the difference. At the top level, that could be the difference for him winning or losing. Yeah. Davis, thank you for joining. I appreciate you all for hanging out with me tonight. Very chill stream. Starting out by going over the Kaggle competition that we had launched. Someone won this GPU back here. By the way, let me pull that up. I'm going to be mailing this off soon. We did give this away as a prize for our Kaggle competition to the top place winner. So congratulations. And we are going to keep that up, hopefully, and do some more of those later on. But in the meantime, let's talk about a few things I have going on. So !YouTube will bring you to my YouTube channel. If you haven't seen it yet, check it out. Please subscribe there. I make videos about data science, machine learning, that sort of stuff. You can also do !Kaggle to check out my Kaggle profile. You can also check me out on Twitter, Rob_Mulla. I will put that here. And also don't forget about our Discord. So feel free to join our Discord. It's not like super active on there, but you know, if you want to ask me a question, that's the best place to ask it. And if you want to talk more about what we talked on stream, that'd be cool. Okay, so I think that's all the stuff. Now what we're going to do on Twitch is we are going to raid someone. So Midnight Simon and Time Enjoyed are both streaming. Both great streamers. So what do you guys prefer in chat? Do you prefer seeing some leak code, like competitive coding, or someone who's doing web development with Python and Django? Oh wait, Nick is also streaming. Let's raid Nick. Is he around? He's not on screen though. Nick Wan, where are you? Leak code, people say. Where in Maryland are you? I'm right outside DC. Not to dox myself, but okay. I would raid Nick, but I don't see him on, like his screen is just frozen. He's not at the keyboard. AFK, I guess. All right, we're gonna raid Midnight Simon. He's super cool. Stick around and check him out. And I will see you guys next time. Maybe Thursday, possibly Sunday, probably Thursday. But Tuesday, Thursdays, Sundays are my usual nights where if I do stream, that's when I stream. I hope to see you all soon. Let's get some some awesome data science. Let's find out chess cheaters by using data science. All right. See you guys next time. Bye. Bye-bye, YouTube.